Welcome you all. I'm Dr. M.Tamilselvi, Assistant Professor, Department of Chemistry, Sita Lakshmi Ramaswamy College. In this video, we're going to discuss the topic energy and matter. Energy is first defined in this presentation, followed by which we're going to discuss the three states of matter. Later, we're going to describe the intermolecular forces or IMF, followed by which we're going to find out the relationship between intermolecular forces with melting point and boiling point. Towards the end of the presentation, we're going to understand the different phase changes. Energy is defined as the capacity to do work. Potential energy is the stored energy, whereas kinetic energy is the energy of motion. The law of conservation of energy states that the total energy in a system does not change, or in other words, energy cannot be created or destroyed. The two units of energy are calorie and joule. Joule is the SI unit, and 1 calorie is equal to 4.184 joules. The slide right here shows the properties of the three states of matter. Gases, as we see, have no interaction between the particles. Therefore, the particle movement is very fast and the arrangement of particles is random and far apart. In the case of liquids, the interaction between the particles is strong and therefore the particle movement is moderate and the arrangement of particles is random but close enough. In the case of solid, the interaction between the particles is very strong. Therefore, the particle movement is slowed down and the arrangement of the particles is found to be fixed. So, there is a term which is called as intermolecular forces or IMF. These are the attractive forces that exist between the particles. The three important types are London dispersion forces, dipole-dipole interaction and hydrogen bonding. The strength of the intermolecular force is what determines the boiling point or the melting point. Now, firstly, we are going to look into the London dispersion forces. These are very weak interactions and they are due to the momentary changes in the electron density in a molecule. The weak interaction between the temporary dipoles is what constitutes the London dispersion force, and all the covalent compounds exhibit this London dispersion force. The larger the molecule, the stronger this London dispersion force is going to be. Here in this slide right here, towards the left hand side, we see the picture of a gecko. Geckos stick to the walls. They climb up and down, and this is because of the millions and millions of tiny hairs in the foot which is capable of exhibiting London dispersion forces. Towards the right hand side of the slide, we see two methane molecules and how London dispersion force exists between the two molecules. The second type of IMF is called as dipole-dipole interaction. These are attractive forces between the permanent dipoles of two polar molecules. Here in the slide we see formaldehyde molecules and how dipole-dipole interaction exists between them. The same could be shown with the HCl molecule too. The third type of intermolecular force is called as the hydrogen bonding, and it occurs when a hydrogen bonded to oxygen, nitrogen or fluorine is electrostatically attracted to an oxygen, nitrogen or fluorine atom in another molecule. So in this slide, we see two water molecules. The red balls represent the oxygen atom and the white balls represent the hydrogen atom. And the dotted lines represent the hydrogen bond between the two water molecules. Hydrogen bonds are the strongest of the three intermolecular forces. Hydrogen bond is also existed in the DNA. The role of hydrogen bonding is very important for the proper functioning of DNA. The intermolecular forces are summarized in this table right here. London dispersion forces are weak in strength and it's exhibited by all the molecules. whereas dipole-dipole interactions are moderate in strength and they are shown by molecules with a net dipole moment. And the third type, which is the hydrogen bonding, is the strongest in strength of all the three, and molecules with an OH, NH or HF bond exhibit this hydrogen bonding. Talking about the relationship between the IMF and the boiling point and the melting point, we find that the stronger the intermolecular force, the higher the melting point and the boiling point. So, the compounds that have hydrogen bonding present in it have relatively higher melting point and boiling point. For instance, we have the methane molecule and the water molecule. The boiling point and the melting point of the water molecule are very high, which is about 100 degree and 0 degrees, compared to the methane molecule, which has a boiling point of about negative 162 and boiling point of negative 183. This is because in methane we have only London dispersion force, whereas in water molecule we have the strong hydrogen bonding present. So talking about the relationship between energy and phase changes, we will need to be familiar with the two terms, endothermic and exothermic. So when energy is absorbed, a process is said to be endothermic. When energy is released, the process is said to be exothermic. In a phase change, the physical state of a substance is altered without change in its composition. This is the first type of the phase change, where the solid is converted to the liquid. And this process is called as melting, and this is an endothermic process. When the reverse happens, that is the liquid is converted to the solid, it's called as freezing, and this process is exothermic. The amount of energy needed to melt 1 gram of a substance is called as the heat of fusion. The second type of phase change is exhibited in this slide right here, where the liquid is converted to the gaseous form. This process is called as vaporization and is endothermic. The reverse, when the gaseous substance is converted to a liquid, is called as condensation and it is an exothermic process. The amount of energy which is needed to vaporize 1 gram of a substance is called as heat of vaporization. The third type of phase change is conversion of the solid into the gas. And this process is called as sublimation, which is endothermic. And the reverse, when the gas is converted to the solid, this process is known as deposition and it is an exothermic process. So to conclude, we have seen that energy is the ability to do work. Its SI unit is joule. Whether a substance is going to exist as a gas, liquid or solid depends on the balance between the kinetic energy of its particles and the strength of interaction between the particles. Intermolecular forces, or IMF, are the attractive forces that exist between molecules. The stronger the intermolecular forces, the higher the boiling point and the melting point. Finally, the phase change is nothing but a change in which the physical state of a substance is altered without change in composition. Thank you for your patient listening.